Have you ever looked up before, perhaps through binoculars or through a telescope, and seen a planet with a beautiful and awe-inspiring ring system? Or perhaps you've experienced this through a picture that you found online. You're likely already thinking of the one I am describing here without me even naming it. And while there is more than one planet in our solar system with rings, none of them are quite like the sixth planet from our sun. This is Cup of Science Joe, and today I'm here to talk about my favorite planet, the gas giant Saturn, and we will explore the planet itself, its unique rings, and some interesting things about the Saturnian system. Now, Saturn comes in at about 886 million miles from the Sun, and as I mentioned earlier, it's the sixth planet in our solar system. And like Jupiter, it is huge, big, massive, though not quite by as much. Saturn is about 75,000 miles in diameter, making it around 9 times wider than Earth. And if we wanted to fill Saturn with Earths, we would need 764 of them or so. Saturn is the farthest planet we can see with the unaided eye. This means it was not really discovered in any way that we have recorded, and has instead been known since antiquity. It is named for the Roman god of agriculture and wealth, who was also the father of Jupiter. Fitting, as that in mass anyway, the Sun overtook his father. But in my opinion, he didn't overtake him in majesty. Being a gas giant, Saturn itself is not conducive for any form of life as we know it. The pressures, temperatures, and materials that characterize the planet are likely too extreme for any sort of life to form. Not only that, but with no hard surface like the terrestrial planets, anything that was there would need to be able to move through the atmosphere, lest it fall towards the core until being crushed or immobilized. This would go for us in a spaceship too. If we were to visit Saturn, not only would we have nowhere to land, but if we flew too far into the planet, we would be crushed and vaporized. Now, while we have likely ruled out the planet itself in terms of the ability to support life, we can't rule out the system, as Saturn has moons potentially possessing subsurface oceans which could have a chance of harboring life. More on that one later. Now, have you ever wondered how Saturn got its impressive ring system? The prevailing thought here is that they are composed of pieces of comets, asteroids, and shattered moons that broke apart before they reached the planet, getting torn apart by its powerful gravity. They are made up of billions of small chunks of ice and rock, sometimes coated with other materials such as dust. And these particles in the rings, they can vary in size quite a bit, from as small as a tiny dust-sized icy grain to chunks as big as a house. And it even goes up from there. There are a few particles or chunks, whatever you want to call them, that are as large as mountains. Now, if you were to be situated in Saturn's cloud deck and you were to look out towards the rings, they would appear to be mostly white. The ring system is wide as well, but relatively thin in comparison. It extends out about 175,000 miles from the planet. Yet their vertical height is a mere 30 feet. That is quite a difference. And because they are so thin, there are times when we are oriented in a way with Saturn such that they effectively disappear from our view when we try to look at it. This is because during these times we are edge on to the rings instead of seeing them at an angle. In total, Saturn has 8 rings that make up its overall ring system. Like its giant counterpart Jupiter, and also our Sun, Saturn is made up mostly of hydrogen and helium. Now, its core is dense and made of metals such as iron and nickel. This is surrounded by a rocky material and other compounds that have been solidified by the intense pressure and heat. And then this whole core is then enveloped by liquid metallic hydrogen that's inside of a layer of liquid hydrogen. And like I mentioned before, I really think that this progression down towards the core changes those states, not only because of what it's made of, but because of how much increased pressure is put on the next layer. Now, this next part might be kind of hard to imagine, but Saturn is the only planet in our solar system with an average density less than water. This means if you had a gargantuan bathtub filled up, Saturn could float in it like a toy, like a duck, like a rubber duck. Saturn is blanketed with clouds that appear as faint stripes. Jet streams and storms are making this. This makes the planet many different shades of yellow, brown, and gray. The winds here on Saturn are quite fast as well. In the equatorial region of the upper atmosphere, these winds can reach up to 1,600 feet per second. Really fast. For a point of comparison, the strongest hurricane force winds that Earth experiences top out at 360 feet per second. So quite a difference there. And Saturn's North Pole has an interesting feature, a 6-sided jet stream that makes like a hexagon pattern. This hexagon-shaped pattern was first noticed by the Voyager 1 spacecraft, and it has since been more closely observed by Cassini. The jet stream itself spans about 20,000 miles and is somewhat wavy in nature. The winds here are around 200 miles per hour, with a massive rotating storm at the center. From what I could find, there are no other weather features like this anywhere else in our solar system, just adding to the uniqueness of the planet itself. Now, as I mentioned earlier, Saturn itself is likely unable to support life. But this is not the case for some of its moons, and there is one moon in particular that I would like to touch on today. The moon known as Enceladus. Now, there are few worlds in our solar system that are quite as compelling as Enceladus. A small handful of them are thought to have liquid oceans, such as Jupiter's moon Europa, and these liquid oceans would be found beneath their thick icy shell. But Enceladus takes this one step further for us and sprays its ocean out into space. This gives us an opportunity to sample it with spacecraft. In fact, this has already been done by the Cassini mission. Now, I think this moon, along with some others from the Saturnian system, really do deserve a video of their own. But what we've gone over here briefly will help lead us into what I would like to leave you all with today. And that is, even if a planet itself is not fit to host life as we know it, one, I just find it exciting to explore and learn about the planets themselves. But it also does not mean we should rule out its overall systems or moons. We just might discover life outside of Earth in a place we may not have originally expected. This is why I believe it's important for us to study and research not only our solar system, but space and the rest of the universe as well. Now, if you would like to learn more about another one of the gas giants in our solar system, Jupiter, then check out this video right here. Otherwise, I implore you to step outside tonight and look towards the stars.